Should I start?
Yes, no. Do start.
Okay. Hello. Hi everyone. Can everyone hear me? Yes? Okay, thank
Yes.
you. It's very good to see everyone. My name is Esther. I recognize some people from the audience. I saw Jeff. Um, So Jeff and I, we both work at WSP, and I actually started working with Peter the end of 2019 um, to co-chair on this group, and it's been a tremendous, wonderful experience to be able to participate and learn with everyone. And Happy New Year! It's 2021, so it's another year. I hope it's gonna be better than last year, and we will finally get a better handle of COVID situation. Um, and without further ado, we'll kickstart this year's meeting. Um, Again, my name is Esther, and today we're gonna be looking into the built environment for the next 100 years. There has been a lot of report um, and studies about the climate change and how the built environment increase the pace of global warming, um, particularly from United Nations. There has been paper released, and also from Paris agreements, the um, the 21st conference of global warming at Paris, COP21, and it leads to IPCC, the 2018 report. And so I built this presentation based on those reports. We will be looking into the data that's been mentioned there on this report, and how can we respond to the data and the projection of what will happen in the next century. So we all know that with global warming, that we have bigger, badder storms, natural disasters, wildfires everywhere that's happening um, globally, um, and that really affect our professions.
Why not?
Go.
What?
And as I put together the presentation, this presentation will be looking into how the built environment impact the climate change and global warming, and we can be more aware of the environmental and humanitarian crisis that's caused by us as a profession, because we are the builders, the architects, the engineers, and the contractors, the overall AEC, the industries that's building our civilizations in terms of the built environment. And so once we recognize our task, that we will be able to um, get a better handle of the situation to reverse the crisis. And also we'll be looking into several build projects that aimed at mitigating the effect of the building footprints to its surrounding environment. So based on the report released from IPCC, that we might heard oftentimes that people talk about a lot about it, about how the temperature is increasing. It's getting warmer and warmer, and there's a threshold that's established for 1.5 increase Celsius to 1.5 to 2 Celsius increase. It's a very little number, 0.5 degrees, but that actually have a huge, tremendous, a big impact in our overall environment. Um, we had to deal with the rise of sea level, the heat wave, the big storms, the mega storms. Um, Not to read from what the report says, but our rainforest will turn into savanna, and the heat wave um, will make people to relocate, including the floodings and the rise sea levels. And the way that we're building, um, so we're building two today that the global building floors, it's about 2.4 trillion square feet. By 2060, this number will be doubled. So that means we'll be building a New York City every 34 days, almost every month. And um that's a lot of building. Um and in order for us to reverse our our I don't want to say the word that damage that we caused to the nature, um but um the temperature will keep rising, and once when it reach certain threshold, there are things that changes that we cannot reverse. And we there has been a lot of ongoing efforts like 2030, 2040. There are specific milestones that's being set up for us to work on. So the climate change that can be irreversible, we could dial it back. At least we could slow it down in terms of our in terms of the way that we build as overall um, professions. So mitigating the impact of our effort, I mean of our built environment, w- we have been trying to address this challenge since 2006, 2009. Um, and the, there are a more um, effort in terms of pointing where to look and how to address it. Um, One have been saying that um, in order to really reduce carbon emissions, we should be looking at operational carbon of the building and also embodied carbon um, re- emissions. So operational carbon of buildings, it means the MEP aspect of it, the HVAC, the air conditioning, the lighting, and so all those energy consumed during the operation, it's actually a very big problem to tackle. We could, and that's something as an architect that could do, is to improve it with envelope design and increase system efficiencies in order to bring those emissions down. And it's an ongoing process. The recent report just released back in 2019, um, we have been able to cut down the CO2 17.8 millions of metric tons. That's like planting 21 million acres of forest. So there's been progress that's being made to to um to reverse the problem.
Hey.
Um, as we mentioned, operational carbon and reducing, and another effort that we could do is to reduce the embodied carbon. Um, that's the embodied carbon in general is the raw material that from how we source it and manufacture it and ship it and all the way on site until it's built. And that is a lot of use of energy there. And if we could find a way to reduce that use of energy that's cost, that would be really great. And there's been a lot of effort um, being made that people to encourage our clients, if that's an option, to when choosing a site, an existing building or building a new building, um, it's being encouraged to choose an existing building because that retrofitting it really save a lot of energy in terms of using new building materials like concrete and steels and all that. And concrete and steels has always been considered as a major building material whenever we build new buildings, new constructions, and that contribute to the embodied carbons. Um, what's being said is at the end of 20th centuries, there are many buildings that's been built with very little concern of energy efficiency, and that's what's available right now. And if we could further upgrade and adopt those buildings, that will um, to make it more energy efficient, that's another effort that we could do um, to cut down the embodied carbon footprint. To AIA has a lot of materials in terms of overall approaches, the whole building approaches to emission reductions. And I also have the reports and the data available. If you if you guys are interested, I could send it out after the meetings. So without getting too much into the details. Another way we're looking at is the design guidance. It's the overall building approach. We as I emphasized, to use or repurpose existing building and to that really cut down the embodied carbon emissions, and also use recycle or salvaged materials. Um, that's an option if we have an existing building in hand to work with, and specify material that's manufactured with renewable energy. Um, if that's an option, of course. Most of the time it is not. Um, and a lot of emphasis in terms of design approach is to use it for some the materials. I think there is an encouraging approach to ask people to specify um, recycle or local source the material, so it doesn't have to be shipped or transported from a long distance, and including the transportation itself. It would be really great if that we could use low emissions transportations like barge or train, um, so they don't have to ship it from far as well. Definitely not shipping something from a different continent. I don't think that's an encouragement now. I think what people are trying to do is like shopping locally, and that's the same thing with building materials. And if you get in contact with your supplier, manufacturer, usually have transport center nearby, or they could manufacture the material within the US, and that way that there are a lot of energy that can be saved in there. Um, so overall, again, I'm gonna refer to the 2030 commitments that's being posted by AIA, that they have the resources available on their website, and to talk about how to address your project. And it really varies from side to side. And we're seeing a lot of emphasis on where the the, the immediate problem is, especially around the coastal area, because of the elevated sea level. So there are a lot of attempts trying to solve, um, to adapt to the new issues that we are addressing at hand. Um, Coastal adaptations, living shorelines, and the settlements, um, and habit, apart from the sea level, the local regional habitat corridors, and lake buffers, riparian buffers as well. So all these informations, they have more details on the AIA website. Cities, if we have a site at a city, a building at a city, again, there's a lot of emphasis on urban infill and retrofitting, um, encouraging bikeways, biking to where you work, to back and forth to where you live, electrical vehicles to reduce energy use, carbon emissions, and complete streets, to build your streets to make it more pedestrian friendly, interactive, encouraging interactions among people and vehicles to slow down. It's another approach. Transit-oriented development center around major public transportations, and site. It depends where the site is located. Again, um, you could elevate your structures, or that allows water um, to move and mitigate freely on the drains away from your building when it floods. And the vegetative coolings, this is for um, a warmer climate, that you can actually have a green walls on your building envelope. And a quick glance at the 2019 report that's being released. It's been a work in progress. So there's a huge reduction on the energy use, 49%, and the data it's been collected from 311 companies. And project reported is 20,331. So, and the metric tons of CO2 emissions is being avoided. As I mentioned, that it's equivalent to about 21 rainforests, um, 21 million acres of rainforest um, s- been planted. So there's been a progress about of this effort. Instead of um, advocating it, discussing in ongoing conversations, we're starting to see the process and the effort that's being put into the the big topic of climate change. It's actually happening every day in our life. Um, and again, the, I do have more detailed information. If you're interested, please feel free to reach out to me and I can email those data to you. And briefly, we will be looking at the project that's being built at, that with the net zero approach in mind. So this is in Texas, Austin, Texas. This is a adaptive reuse of a local building, local recycle centers that is being transformed into an office building. What you see is the new, so the so this is the metal roofing and this is the structure that's being exposed, and what's inside of it is recessed wood panels from the recycled wood materials. Um, what's really great about this project is the budget, the cost. It was being reduced tremendously. In Austin, it's about in this neighborhood. It's typical for this type of project. It will cost 150 dollars per square foot. Um, but it finished. The project was able to achieve its goal by around $85 per square foot. So there's a huge cut in terms of the budget and the cost of the project. And they were achieved by using recycled materials. Um, wood and building adopt from existing buildings. So that's a so you don't have to specify new concrete, new steels. You with a if you work with an existing buildings, you could it could really save a lot of money there. Um, and they also work with the local artist. In Texas in to revive the local neighborhood and because it was abandoned and the neighborhood was abandoned, and because of this effort, they're starting to bring back people, the offices, the business, and the shops. Once when there's office there, there's business there, the shops comes, and once when people comes, um, the the neighborhood will slowly to come back alive again. Um, s- Again, so those are the different images of the same project. And right now, this is we're looking at the New York City. Um, this is also working with an existing building. It's actually 50 years old with lots of glass. The the sustainable effort in here is to update the MEP mechanical electrical systems, especially and introduce Energy Star equipments and then appliances. So all the light fixtures is on a timer, and there's also vacancy sensors. So that being said, they rely a lot um, on the daylight harvesting. Unfortunately, I think that's one of the strengths of this building because it has so much glass that you really can take advantage of that. And with the sensor smart technology, there's a huge savings in terms of electrical bills, operation cost. Another big effort of this project is the, the the garden inside the atriums is being installed with I mean planted with a lot of local vegetations that will survive indoor um, and make it a more welcoming and happening place for the people inside the city. Those are the pictures of the buildings as you could see. And this is in California. It's a preschool emphasis on nature and its surroundings. What's really unique about this project is the cross ventilation that's been designed. This is a new construction. And it does not, in this particular project, it does not have mechanical heatings. It relies on natural ventilations. And as you could see that it has um, cantilevered, really big overhang to and opened up sections to encourage cross ventilations on site. Um, and and also what they utilize is the photovoltaic panels on the roof that allows to harvest solar energy solar energy um, at California. And the open space, the environment, again, it's incorporated with native plants to preserve and protect the ecosystems, the local existing ecosystems. And this is more pictures of the school inside the building. And another project we're looking at is the Austin Library. What's really unique about this building is it is an existing building, um, but it has a tremendous the biggest, I believe it's one of the building that has um, the biggest daylight harvesting atriums. That it has a study of every floor, s- um, six f- s- eight, 6-story tall, and it has a view. You have s- exposed to every angle of the buildings and to the surrounding area. It really take advantage of the views and the daylight and the rainwater harvesting collected to irrigate its landscape and plumbing toilet low plumbing systems that can be reused. And this is the inside of of the building to see the daylight harvesting conditions. The more image of it. And now we at the New Mexico again. There's a very big effort that's try to build to be friendly to your site to integrate the proposal into the local Harvard ecosystems and landscape. Um, that there's been a lot of study put it into how to preserve the local desert environment and water preservations. So this and marine. So this is the Gulf Coast Research Laboratory. Because of the elevation, the floodplain, there's been a lot of studies being putting into how to mitigate and locate the building away from the flooding paths and local plants that can be planted in order to preserve the environment. Um, this is actually in no I believe it's in Finland. Um, it's it's by Big. It's a Norwegian manufacturer and urban furniture company. What they propose to do is to build the factory um, within the forest and to incorporate it um, into the area so they can plan other programs including hiking trails and pedestrian activities that could be going around within and out the buildings. But this is not a build project. I only put this in as a reference of what companies are doing um, in terms of when they're developing project in a conceptual stage. Um, Maybe I should stop the presentation here because I'm trying to emphasize on what's already built. Um, and open up for questions. Um, do we have any questions? Peter, do you do we have questions in terms of pages that you want to revisit?
I'm trying to see whether we can unmute, allow participants. I'm going to request that participants who have questions unmute yourselves. I've just turned that on. I hope this will work for each one of you who has some ideas. Let's start with that. We have a large number of attendees, so there should actually be some questions. Are any of the attendees?
There are questions showing up in the chat. You need to look at the chat. There's someone asking from Jeff Berg about details of the Austin Library daylighting.
Okay. Let me see.
Chat. Good.
So the library. Um, I apologize, but I didn't see the questions. Let me see.
Oh, I I just would like to know more about the details of the daylighting of the Austin Library.
Yes. Okay, so they so they did a study to focus on how daylight could be harvested from
Mhm.
different location of the building. So you could see from this particular slides that there's analysis that's been done for high visibilities to low visibilities. And as you could see that it's it's mostly high visible within the building for daylight harvesting, that the building is really is taking the maximum advantage of the daylight. So it's mostly blue. The very little gray areas are mostly the utility function of the building, like restrooms, um,
Mhm.
um, maintenance areas. But the building from floor 1 to all the way to floor 6, it's a very well lit. It's very bright inside. And
Well,
So the approach is mostly, it seems to be about massing and planning.
yes, and
So it's not, it doesn't appear, and that's fine, but it doesn't appear that there are any special devices that are enhancing the daylighting,
uh special devices as
like
as a material.
mirrors or
Oh,
um,
okay.
motorized shades, anything like that.
No, but not that I am aware of, but what I am based on what my reading is that it's they're trying to avoid glares. There's been study in terms of how to have a comfortable daylight inside the building. So avoiding glares and even distribution of the daylight and skylights. There was a lot of study on that. And
Mm.
I think I believe there are passive elements that's being installed outside into like fins and louvers and
Oh,
canopies
okay.
in order
Yeah.
to direct the to guide the daylight entrance, how daylight distributions.
Hmm.
I would
Okay.
like to add to that question of Jeff's. I used to be part of a company that was called Sundelier, and it brought uh, the equivalent of 10 suns into the building by having a satellite-like tracking station on the roof of several buildings in Denver. One, the central uh, building in Denver itself, a school in Denver, et cetera, et cetera. The idea being that the inventors were engineers who said, look, if we can track satellites, why can't we go and track the sun? And they found a way to harvest the sun with parabolic mirrors, send it to a central distribution mirror, and that mirror blasted 10 sunlights, the equivalent of 10 sunlights, so enormous amount of energy into a tube that was pumped into the building. What that company never did, because its principals, both the chairman and the president, were guys who came out of the manufacturing world. So they were product delivery people. They had no patience for what they called research and development. But what the company has since failed, by the way, I lost a lot of money by joining it. And the reason is they would not listen to the need for such a nice idea to actually be ready for the application by an architect. So if we look 20, 30 years into the future, this idea may very well be revivable, but it has to be accompanied by a way of distributing these 10 sons into various branches so that it doesn't overpower the lighting of a particular space and instead diffuses it and redistributes it. That's a huge design job so that the product itself is shelf ready for an architect to apply to any particular project. So this is something for the future. Another element in the future in terms of constructing for the next 100 years is to really focus on what has been learned in the modular manufacturing industry. Many buildings have, since I was involved in this in the late 80s and 90s, have been built using modular manufacturing. In particular, the most impressive ones were where you had multi-story buildings being produced way off site, like in another state, brought to the site by trucks, hauled up by cranes, and then finished off on site by the local construction industry. The main thing to remember in this looking towards the future is that you try to respect the huge capital investment of a manufacturing plant and to do as much as you can in the manufacturing plant, because that capital cost sunk into the factory will need to be attributed in part to each module that is being delivered. So if the module is half finished and the architect expects the rest of the finishing work to be done on site, the architect is wasting a lot of the capital costs of the manufacturing plant. If you have any interest in this, go and look up the history of Cullman Engineering. It started in the 20s and was a very successful plant. I have documented, but I don't have the documentation anymore, of a building with full brick facade and tiles in the bathrooms being sent from New Jersey up to the Middlesex Community College site, and finishing up with infill, one wide of brick infill and a couple of rows of tiling in the bathrooms, and the job is done. Everything else was done in the factory in New Jersey. Impressive speed accomplishments, impressive reductions of costs. But many projects that have tried to engage in that have run afoul of opposition by labor unions who wish to protect their on-site labor practices rather than sharing the work with people in factories. And so that is a completely separate subject, but it is something to consider for the future. Sorry I was long, but I hope that this helped looking towards the future. Anybody else?
So sometimes, Peter, I think sometimes when you try to build with modular components, there might be resistance from the local unions, and it has to be also size specific and project type. Like it's probably um, very efficient for particular type of project, maybe like residential, multi-families. But when it um, but if it's a hospital for healthcare, or it it might have to be considered case by case. So it I just think maybe isn't it 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 you do have to be site specific and project type specific, and with local and also with local labor markets as well.
Good point. I'm interested and was wondering whether anybody else was also in the project of the Environmental Nature Center and preschool. No artificial mechanical engineering. Boy, if that's in Texas, you've got heating problems. So is the ventilation of basically a
So
breezeway sufficient to make the occupants comfortable enough to sustain them? And I am saying this when coming out of New England experience of a few decades ago, when we rarely had air conditioning and we just lived with by adjusting to whatever the climate had to offer us. That is no longer the case, and in Texas, it must be a real challenge. Do you have any answers for that?
yes, so fortunately this project is it's in California.
Oh, okay, California.
Uh,
It's got problems too.
oh, dodge a bullet. um, but that's actually a very good point. Cross ventilation and high ceiling with fans without mechanical ventilation, HVAC, it could be challenging. And I guess at different regions and different site locations, you do have to respond it differently. But
What,
I just saw maybe it's it's a it's a good project to show it's built and it's recent 2000 back in 2019, and there's been effort there that trying to respond to our challenge environmentally.
but what amazes me is that I see no attempts at actually sucking air through the building via what we have right here, but what the people in the Middle East have practiced for a very long time, a high chimney and letting the air movement begin to suck air up through it. This can be done by whirligigs or by just natural ventilation. Uh, uh, but in any case, these are very simple methods to go and increase airflow through a building without major mechanical and energy consuming appliances. So I would critique this particular building, which I admire for its attempt at using natural resources without learning sufficiently from other examples across the world that have had to deal with this for centuries.
Right, right. It's it, there are really lots of ways that we could do when we're designing our project, and I think this is a really good example um, of how to use passive ventilation without relying on mechanical equipment to
That's what you said.
yeah.
Good. Anybody else?
um,
This is turning into a conversation between three people or something like that. I'd very much like to hear observations from the rest of the people who attended.
and again, I could email you the presentation and the report and the materials if you're interested to look into it for further. Um, uh, I,
The silence is stunning. You must have answered all the questions, Esther, by your presentation.
There are several in the chat room if you look at the
Diane,
chat
how are
room.
you?
Oh, okay. Let me see.
Diane?
Sorry, I have construction going on, so I typed my question.
Aha. Okay, let me go and see what I can find in chat. All right. Is that Diane at Tufts? Okay. I'll read, well, it's so to everyone, you can read Diane's question.
Um,
All right, Diane, let me answer this a little bit. Yes and no. Newer buildings might be designed to be more tight and possibly approach net zero. However, the existing buildings, in terms of total energy consumed to produce a new reusable facility, it has a much lower footprint in terms of new energy, new materials being extricated from the soil and delivered to the site. So this is not a simple one-on-one comparison. That one has to go and take into account the entire life cycle cost of a building, which is fairly close to zero for a reconstruction project in terms of new building components, and fairly high for a very energy efficient new building.
Well,
Tearing
that's
down, okay, you said you asked meant tearing down. Again, embodied energy on an existing building means that indeed there's energy used and required to tear the building down, which has a carbon footprint, and then to go and create a new building. And it really depends on a number of other factors. For example, here in the Back Bay where I live, we couldn't just go and tear down a building and put up a high rise next to one of these brownstones or anything like that. So there are political and code requirements that complicate that question. But the main thing is to remember to do a full accounting and an honest accounting of all the costs that go into either one of the project approaches that you just asked about.
Yeah, I hear that from a lot of people who talk about embodied carbon, but nobody can actually produce some research studies, and that would be really helpful to back up this argument. And I understand that every case is going to be different, but I assume that some smart, Rocky Mountain Institute or somebody has done some research to really quantify the carbon difference between building a new building and trying to retrofit an old building.
I hear you. I don't know that one can really do that in an academically or scientifically rigorous way. I'll give you an example. I thought I tried to figure out the cost comparison of modular construction of some of the buildings that I was looking at with regular construction. Each project becomes a special situation, and in order to do a real comparison, you can't do it because if you build it modularly, you are not building it in conventional way, including maybe tearing down something, and thereby you are not able to compare apples with apples. You can do projections, which is about as close as you can get to your wish to get some research done. Now, this sounds like apologia, but I have not heard of any rigorous study to compare to the two approaches that you have just mentioned. Diane? Okay.
Thanks.
Now, somebody started asking a question. Was that Diane or somebody else? Okay. You know, if there are no more questions, there's no sense in holding everybody up. You've got important work to do. Esther, I think you and I can say goodbye unless we hear from anybody else now before we close the session.
Peter, you have a tag on your jacket that says fossil fuels. What is that about?
Let me show it to you all.
Oh, no fossil fuels. I see.
Yeah.
Okay.
I
I
know.
figured there
The designer,
must be a catch.
the designer didn't have a clue what how to go and project a message. It was one of those well-intentioned kids, probably, who tried to go and have a bar across it, but you can't discern the bar normally. But on the other hand, it makes people look at my chest.
Yeah, it makes you think. I guarantee that.
Anyway,
Well, thanks.
thank you all for attending. I will answer one of the questions by one of the attendees, and perhaps Esther can do it because she was already starting to set this up to distribute the link for getting your credits for attending this Zoom session. And these. Okay, Esther, you see the messages, the willingness to share resources.
Yes, yes, I could. How do I send it to you though?
Well, let's go and have a talk about this and maybe get Susan's suggestions because it can overwhelm. All right.
Okay,
Let's try it. Whether we respond to each request or whether we do it universally. Let's figure that out once we get some advice from Susan because she must have had these kinds of questions from others. Okay.
okay, and
Now,
it would,
one new message.
yes. So I'm gonna post the link again, and if you click on the link, you can fill out your information to get the credit.
Good. Yes.
Where will you be posting the link?
There.
Oh,
Okay.
okay, great.
Okay, you see it. Okay.
So everybody can go and just simply copy that if they don't want to do it immediately, or they can click on it and off they go.
Yeah,
Good.
trying that now.
Thank you. That makes it simple.
And I could email the report and the presentation and the links to you if you send me your email address, or I don't know if Susan can post it at the
That's
BSA.
what I think Susan was willing to do that for us on the website.
That's great. Thank
So
you,
that
Peter.
everybody can go actually hear your entire presentation.
Okay.
Good. All right. I think we can call it a day. Hope everybody is staying safe.
All right. Thank you. Peter, can
Thank you,
I?
Peter and Esther.
Oh, thank you. Thank
You're
you.
welcome.
Thank you for attending. Peter, can I reach out to you
Yeah, just call me.
separately? Okay.
Just call
Right.
me. Let's
Okay.
everybody get leave the thing. I will
The
leave
room.
the session, and you
Okay.
just call me and we'll talk. Okay.
Okay. All right.
Bye, everybody.
Thank
Bye
you,
now.
Jeff. Thank you.